Welcome. So in this class we shall discuss about the reflection and the refraction of light. Throughout this chapter we shall consider that the light travels in a straight path. So this is a ray optics. Okay. So you have read in class 8 the laws of reflection of light. Okay. Now what is medium? What is a medium? You will hear the word medium. Medium means through which the light travels. That means if the light travels through air, then it is a medium. If it travels through glass, then glass is the medium. It travels through water, then water is the medium. Okay. So for reflection, what happens when light travels from one medium to another medium, then basically we discuss about the two things. That when this is the separation between two medium, there is the interface where the two surfaces meets together. That junction is called the interface. Okay, that is this is the medium 1 and this is the medium 2. It may be air, it may be glass. Okay, so this is medium 1, this is medium 2. Suppose a ray of light falls at the interface, that is traveling through medium 1, it is going to enter in medium 2, that it falls at the interface. Then basically two phenomena may take place, that some light will come back to the first medium, some light will come back to the first medium, and a part of it will travel through the second medium. This is the interface of the two medium, medium 1 and medium 2. So a part of the light will come back to the first medium again, and a part will go through the second medium by changing its direction a little bit. Okay, so this is if the phenomenon that the light comes back to the first medium, again a part of the light comes back to the first medium, is called the reflection. And when light enters in the second medium and changes its direction, this phenomenon is known as a refraction. Is it clear? When light comes back to the first medium, it is called reflection, and when it travels through the second medium and changes its direction from the original one, then this phenomenon is known as refraction. Okay, so this is the point of incidence, this is the incident ray, this is the incident ray, this is the reflected ray, and this is the refracted ray. Okay, and if we draw a normal that is perpendicular at the point of incidence, then this is the normal at the point of incidence, then the angle made by the incident ray with the normal is called the angle of incidence, denoted by I. This is angle of reflection. The angle made by the refracted ray with the normal is called angle of refraction. Okay. Now angle of incidence, from the laws of reflection, the angle of incidence equal to angle of reflection. So both the angles are I. If it is I, then it should be I. And this is the angle of refraction. Okay. Now this is the original direction of the light, denoted by the dotted line. So it is deviated by some angle. So this angle is called angle of deviation, denoted by delta here. This is known as angle of deviation. So total angle equal to I. So angle of deviation delta equal to I minus R. So this total is I minus R. Okay. This is the incident ray, this is the reflected ray, this is the refracted ray. The angle made by the incident ray, this is the normal. Okay. And this is the interface of the two surfaces. This is the medium 1, this is medium 2. The angle made by the incident ray with the normal is called the angle of incidence. the angle made by the refracted ray with the normal is called the angle of refraction, and the angle made by the reflected ray with the normal is known as angle of reflection. Angle of reflection and angle of incidence are equal, and this angle is called the angle of deviation. Okay, is it clear? Now coming to the part reflection of light. What is there are two laws about the reflection of light. First law, the incident ray, the reflected ray and the normal drawn at the point of incidence lies on the same plane. Okay, incident ray, reflected ray and the normal drawn at the point of incidence lies on the same plane. This is the first law. And second law states that angle of incidence equal to angle of reflection. Okay, this is the laws of reflection. Don't be confused that this is the angle of incidence or this is the angle of reflection, some kind of these things. Okay, the angle made by the incident ray with the normal is called the angle of incidence, and the angle made by the reflected ray with the normal is called the angle of reflection. Is it clear? Now, in our syllabus, we shall discuss about the curved mirror, that is spherical mirrors, concave mirror, convex mirror, not the plane mirror. Okay, so what is a spherical mirror? Suppose this is a sphere. Now if you consider these parts only, we have this is the center of the sphere. Okay, now if someone cuts these two parts from the rest of the sphere, and in one of the two parts makes a reflecting coating on the inner face, and here on the outer face. So here this is the reflecting surface. This is the reflecting surface. This mirror is called convex mirror and this mirror is called concave mirror. Okay, this mirror is called convex mirror, this mirror is called concave mirror. So this is the convex mirror. The reflecting surface is the outer surface, and this is the concave mirror. Okay, now this is the center of the entire sphere. So for the mirror we use the term center of curvature because it is not the entire sphere. If you consider only the mirror, the spherical mirror, that is this part only, then it is not the entire sphere. So we shall not use the term center here. We shall use the term center of curvature. This is a curvature and this is the center of the curvature. This is the center of this curvature. So this is called the center of curvature. Is it clear? Now the midpoint of the mirror is called the pole. Midpoint, the geometrical center of the mirror. midpoint of the mirror is called the pole. Here this is the pole. Okay, here this is the pole. If you join the center of curvature and the pole by a straight line, then you will get the principal axis. This is known as principal axis. Is it clear? If you join the center of curvature and the pole, you will get the principal axis. Okay. Now, this is the center of curvature, this is the pole, and the distance of the center of curvature from the pole, distance of the center of curvature from the pole is known as radius of curvature. This is known as radius of curvature, denoted by capital R. This distance is known as radius of curvature. Is it clear? For the convex mirror also, so this is the pole and this distance is the radius of curvature. Okay. Now focus. This is a concave mirror and this is a convex mirror. Okay. You should know that the radius intersects the circumference of a sphere or a circle normally, that is at 90 degree, that it intersects the surface at 90 degree. At each point the radius intersects the circumference or the periphery at 90 degree, that is normally. Okay, so if we draw a straight line at any point on the mirror from the center of curvature, it will be the normal at that point. Is it clear? Because it creates an angle 90 degree. Is it clear? I am repeating again. If we draw a straight line at any point on the mirror from the center of curvature, then it should be the normal at that point. Okay. Here this is the normal. Here this is at the point A. CA is the normal. Okay. Now coming to the definition of, and again for this surface, if this is the center of curvature, we use the dotted line because a ray cannot go beyond this mirror. So we have used the dotted line. Okay. So for a concave mirror, a convex mirror, if this is the center, then this is the normal at the point A dash, and this is the pole P. Okay. Now coming to the definition of focus. The rays parallel to the principal axis. So this is the principal axis. This is the principal axis. The rays parallel to the principal axis after reflection on the mirror meets at a particular point on the principal axis for concave mirror. That particular point is called the focus for concave mirror. And what for convex mirror? The rays parallel to the principal axis after reflection on the mirror appears to diverge from a point. From the principal axis. That particular point is known as the focus for the convex mirror. What is converging ray? What is diverging ray? If this is the diverging ray and if the ray meets at a point, then these rays are called converging rays. Okay, so from the definition, if the ray is parallel to the principal axis, this is a ray and this is a ray. Ray is parallel to the principal axis. After reflection on the mirror meets at a particular point. So if this is a ray and this is the angle of, this is the normal, as you know, this is the normal at the point A. So if this is the angle of incidence, so the reflected ray should go in this direction? No, the reflected ray should go in this direction, so that reflected ray should be on the other side of the normal. So this is the reflected ray. The rays parallel to the principal axis, the rays parallel to the principal axis after reflection on the mirror meets at a particular point on the principal axis. That particular point is known as focus. And for convex mirror, the rays parallel to the principal axis after reflection from the mirror appears to diverge from a point on the principal axis. Now, for this case, this is the angle of incidence. This is the normal at this point, so this is the angle of incidence. So the reflected ray should go in this direction, not in this direction. So this should go in this direction, making the same angle. So this is the reflected ray. So for the observer, it should appear to come out from a point, come out from this point, and for this ray, it will go in this direction. Okay, and this is the focus. So repeating the definition again. For convex mirror, the rays parallel to the principal axis after reflection on the mirror appears to diverge from a point. Appears to diverge. It appears to us that it is diverging from the point F. This point is known as the focus for the convex mirror. If you pay attention on my language, that in the first case I use the term it meets at a particular point, and here I have used the term it appears to diverge. I am not saying that it diverges from a point. It appears to diverge. It seems to us that it is diverging from a point. Actually, it is not diverging. It is a ray coming from infinity, that is the parallel ray, and gets reflected from the mirror. But it appears to us that it is diverging from the point F. Suppose I have a plane mirror in my hand, and sun rays falls on the mirror and it goes to your eyes. What, you are sitting just in the opposite direction and sun rays are coming in front of me, and it goes to your eyes, and what will you see? That rays are coming from here, not from the back side of you can't see the entire path like this. You will see that rays are coming from this mirror. It will appear to you all the rays are coming from this direction. Similarly, it appears to the observer that the rays are coming from this point. So this is the focus for the convex mirror, and this is the focus for, and here all the rays will meet at this point. So this is the focus for the concave mirror, and this is the focus for convex mirror. And the distance of the focus from the pole is known as the focal length. This distance is known as focal length. Here this distance is known as focal length. Is it clear? Write down all the necessary points. Don't go through the video class only by hearing it. Take a pen, paper and write down all the necessary points you want. Okay.